All right, jumping into 5.2, we're still looking at these systems of equations, and we're just going to come up with a few easier way of solving these systems than we did in that example we looked at in section 1. So just to jump into it, we're going to be looking at something called a differential operator. And an operator you guys have seen before, but we didn't really focus on it as much as I'd like to. So we're really going to focus on it this time. So just some notation. Your whole life, right, you've looked at derivatives written out like this. So y prime at t, or a different way of thinking about it would be dy dt, or you could just do dt of the function y. All right, so you've always seen it like this in any of these formats, and they all mean the same thing. What you haven't been told is that writing it like this, d dt of y, is writing it like an operator. d dt means nothing if it doesn't have that y function beside it. What d dt tells us to do is it tells us to operate on the function y. In other words, it's a process that you do on the y itself. And then we can take this even further and do second derivatives. So y double prime of t, or we would write this as, I don't know how to say it, the second derivative, right? We would write it like this. Or what we could do is we could write it like this, right? d dt of, oh, that did not work out like I wanted it to. d dt of y. So like that instead. So basically what we're doing is you want to think of this as being a composition. You want to take the derivative of y first, and then whatever that comes out to be, take the derivative of that. So you can operate on an operator operating on a function. That was a mouthful. We're just going to make this look a lot nicer for us from now on. We will use just a capital D instead of, not instead of question mark, sorry, instead of the regular way of writing out the derivative d dt. The reason we're doing that is it's going to make some calculations look a lot better. So just a couple of examples here. Let's say we were given this differential equation, y double prime plus 4y prime plus 3y is equal to 0. If I wanted to write this out using that differential operator, we would write it like this. So d squared y plus 4dy plus 3y is equal to 0. It means the same thing, and I know it looks like it's a little bit more complicated, but I promise you once we start looking into it a little bit more, this will actually turn out to be a very nice way of expressing these differential equations. So we wouldn't leave it like this, though, because we want to leave it as an operator on the function y. So what we're going to do is basically, it's not really factoring, but we want to pull out the operator, where our operator is going to be the d squared plus 4d plus 3, and now it's operating on y. This does not mean multiplication. This is not the y is going to be distributed into this. This is now an operator, and this is telling us how we're going to operate on y. Okay, cool. All right, so just to write out a little bit here, so we are considering D an operator acting on a function. We're also thinking about that d squared, not as d times d. We're thinking of d squared, which you can think of like this. We interpret as a composition of that operator d with itself. Okay, what's really going to be nice and what's really important is that we can take the operators and we can actually work with them algebraically. So let's say we had two different operators. We had d plus 3 and we have d plus 1 operating on a function y. What we can do is we can actually distribute this stuff all together and multiply it all out, not by the y, but the operators themselves. So before we get to the final answer and the shortcut way of doing it, let's do it the long way. The long way of doing it would first operate d plus 1 onto y. So if I do the operation here, d onto y would just give us the y prime, and then 1 on the y would just give us y. Now what we're going to do is we're going to take this d plus 3 and operate that onto y prime plus y. What that means is that we're going to take d and operate that on y prime plus y, and then we're going to take 3 and operate that on y prime plus y. Okay, this d onto the y prime is going to be the second derivative. D onto the y is the first derivative. Plus 3 on y prime is still just 3y prime. And then 3 on y is just 3y. And then combining like terms together, we get y prime, y double prime plus 4y prime plus 3y. If I wanted to write this out as its own operator, this would be d squared plus 4d plus 3 operating on the function y. All right, the whole point of this is to show you that if you have two operators, d plus 3 and d plus 1, acting on a function y, what you can do instead is that you could just FOIL or multiply out these as a binomial and make it d squared plus 4d plus 3 operating on the function y, and these two things are exactly the same. Okay. Another nice thing about this is that it is commutative. So this is a separate little thing down here. I don't know how to spell commutative. Nope, got it wrong. Communicative? Is there really supposed to be a C there? I don't know if that's right. We'll go with it. So another thing about this is that if you do have the operator d plus 3 times the operator d plus 1, this is the same thing as the operator d plus 1 times the operator d plus 3. So if you are looking at operators, they are communicative. So you can change the order of them and you still get the same thing. Where you have to be careful is that this only works for constant coefficients. So just as an example, it does not work for operators that look something like this. So if you have something like d plus 3t and then another operator d plus 1, you cannot change the order of these. This is not the same as d plus 1 times d plus 3t. So you just have to be a little bit careful. As long as you have constant coefficients, you're allowed to change the order. Not so if you have variable coefficients in your operators. Okay, the whole point of telling you all this is that if I write out a differential equation using these operators, so if we write out a differential equation using operators, then we can solve algebraically. Just like if we had something like this. So just a system of equations. 2x plus 3y is equal to 4, and then another equation, 6x plus 9y is equal to 0, let's say. So the way that we solve these is going to be the same way that we solve a system of differential equations when we have it written out in that operator. Before we get to an example, I just want to write it all out as generic as possible. So we will formalize what we're going to call the elimination method. And this is the same elimination method that you would have for an algebraic system. So two generic differential equations, a1x prime plus a2x plus y prime plus a sub 4y is equal to some function f1. And then we're going to have the other equation from our system, a5 x prime plus a6x plus a7y prime plus a8y, and that's going to be equal to f sub 2. I'm not so sure why the book uses all A's and they don't switch from A's to B's, but maybe it just looks a little bit cleaner doing it this way. So what we're going to do now is we're going to rewrite our two equations here, but using the operators. So that first equation is now going to be a1d plus a2, that operator acting on the function x, plus, and then from these other two terms here, a3d plus a4, that operating on the function y, and it's still all equal to f1. Rewriting the second equation now, the operator a sub 5d plus a sub 6, that operating on the function x, plus the second pair of terms, a sub 7 d plus a sub 8, that operating on the function y, and still f sub 2 on the other side here. Okay, so from here, we're going to use the elimination method, and it's a little bit complicated. So basically the way that we're going to be thinking about it is that we're going to have to multiply one of the functions so that if you do add the two functions together, we cancel out one of my functions x or y. I do have a generic way of writing this out, but I think I'm going to save that for the next video. So I'm cutting it off here. In the next video, we're going to do one example, and then after that example, we'll write out the generic way of doing it. I think looking at an example first will help make this look a lot better. So I'm going to cut it here,